right. Then we'll bring it out here so we can play with it. Okay, and we'll turn the heater back on. All of them.
How many heaters are there?
2 heaters. There's one heater, this is the hot end that makes the filament hot so it can be extruded. And then there's another heater in the bed. That's what all those silver coils are. So it has a heated bed for the filament, you know, for the print to actually sit on as it's being worked.
See, I realized that I had forgotten to change one important thing is every extruder design has what they call the steps per millimeter. So how many revolutions the motor needs to turn in order to extrude a specific amount. Very, very tightly controlled amount of filament. And I didn't do that yet. Aha.
That's why you're here.
Maybe wrong. So I'm just checking the original.
Are those the specs?
Actually, it's very close. It's set to 496 steps per millimeter. And I wrote down what we needed here. And I have little notes. And we need 492.45 steps per millimeter. And we're at 496. 492.5. Okay, and we're going to save. And we're going to have to restart it again.
I did print those out.
Okay. I think.
Shut it off. It's not turning at all.
I'm not quite sure what it's doing there. I think maybe we need to check the motor wires real quick. Okay, so we're gonna have to stop it again. Yeah, I don't have to worry about this too much. I think I've got the amps and voltages set right. I just think that maybe we have 2 wires that are flipped around for the motor. Let's just keep it heating. Moment. Okay. And actually, now that I think about it, the stepper drivers don't like having the wires unplugged with the power on. So we actually are going to have to power the printer down. Yeah.
Center button on the battery.
Okay. Yeah, right. Center button.
Push and hold. Done.
Okay. Whee! Clamps.
Here.
Okay, beauty. So let's just pull this out first. Pull this out. It's a little bit of a rat's nest in here. I wish I would have remembered that we had to bypass that wire. I would have brought another connector. Okay, let's see here. I think I can do this.
And I do have another complete wiring harness for this. Yes.
Okay, well, let's just try this one real quick here. Because the way you check these is on this connector. I have a little piece of wire or something that I can bridge 2 of those.
Well, you want to just pull this cover off? It's just 2 screws.
Oh yeah, let's do that. black.
And that
Yeah,
is just, that
perfect.
is just sitting there.
Yeah. Yeah, that's fine. Ooh, and it's hot.
It's hot.
Ow. You should feel this difference. Okay, just try to turn that. Right? Difficult?
Okay.
No.
Oh, be darned.
See?
Huh.
And what I discovered is that the red one and the black one are a pair,
Yeah.
and so they're the green and red need to be reversed,
Okay.
so that we have, because this connector that goes up to the controller, the pairs are side by side. So if there's a pair that's divided by another one, then all you have to do is move that one, and then it's fine. It doesn't matter how the coils are energized. The only difference is if you wire them backwards, then the motor will spin the other direction.
Right.
And then you just have to fix that in
Right.
the firmware. Okay, so in order to make that change, I think we're just going to do it right here, because I believe that we do this on purpose. That's... Come on. See, this is part of my
not.
fingers, and I get cramps, and I
Yeah.
can't even move my hands.
Yeah.
Is this old age?
No.
No. Well, I was going to pull that off like that, but I think you're right. Now, did you say you had another connector? Let's just go straight to that one. Now that I've done that, black and red, which is actually yellow and red, are a pair. Okay. Oh, actually, I'm going to keep that too. Yeah, okay. Nice. Starting from scratch, basically. Okay, and that much. There's your spare.
So you're rewiring the motor?
Yeah, yeah. The motor leads were backwards, which is why it was making that really strange noise. But if you followed the color coding, what he did was logical because the colors matched. But unfortunately, every manufacturer chooses a little bit
Has
different
their
wire
own
color.
idea, yes.
So we just need to
You want tape or heat shrink?
heat shrink.
Got it.
Heat shrink. That one. Yes, thank you.
More?
We'll need 4 of them, I think. Still trying to find pairs here. What's interesting is that this wire that we just brought out, the colors are different on that one too.
Oh, jeez.
There you go. So it's gray and red now, instead of yellow and red, or black and red. Pick your color. Okay, so these are a pair, which means this would be another pair. Just there we go. Thank you. Now, connector's getting a little bit. Why don't we just skip the connector and just go straight into these wires, because this is getting a little bit long in the tooth. I think that this wire is very close to breaking.
Okay. Like that?
Which that would have killed
Yep.
your 70-hour print
Yeah.
on hour 68.
Right, right, of course. It's the way it normally works.
Let's just wire it in.
Let's do it.
Okay. Interestingly enough, gray and red are a pair over here. No, they're not. Gray and yellow are a pair. But I'm just going to cut this little guy off. Right there. Okay. More stuff. Now, ideally, I would have brought all kinds of fancy connectors and solder, and, but I think this is going to be just fine, considering the number of times that we've made modifications.
Made modifications in this machine, yeah.
How many times do you guys think you modified it?
Can you count that many times?
8, 9 times at least, because this was the first one. Steve built this one as a commission for me.
The first
So
printer.
the very first printer of this size. So it came with all the bugs already installed.
Yeah.
So we had other things to take care of as we were moving along. And then Steve would come by and say, "Ooh, look what I got!" And some new attachment, some new motor, some new extruder, some new. He said, "Let's try it out." So this has always been the test bed, and you've built what, 4, 5, 6 of these now?
5.
But 5. So there's 5 more of these out now.
And you're still my test bed. Actually, my latest thing is doing a dual extruder, right? So I'm actually testing that
Ooh,
on my own printer.
ooh. Well, how come I didn't get to play with that one?
Well, the main reason, if it breaks here, I've got to drive down and fix it.
Well, that's
here.
true.
If it breaks at home,
That's
I
true.
can just fix it there,
Yeah.
and then I bring you something that
Yeah,
actually
see,
works.
so Steve invents it, Steve makes it work, and then he puts it out in the real world for the idiots to play with and see if we can break it.
And if anybody can break it,
Hey!
oh boy. Okay, let's see here. Heat shrink. Okay, I got it. Do that. Oh, you got more. Okay. We're gonna start with red. So red to red, and then we're gonna go black to gray, because we tested black and gray, and they were a pair.
Do you want to heat it, or you just want to slip it on?
Let's just slip it on for now, and as soon as it works, then we
Then
can
we'll
heat it up
seal
and
it
be done
up.
with it.
Gotcha.
And what I'd like to do is I like to twist these really tight,
Yeah.
and then just put a little knot on the end of it, like that,
Yeah.
right? And then when you put the heat shrink on over top of that, it's like a it's like a solder, basically. And there. And my hand's cramping again. Okay, let's see. I have done this quite a number of times over the years.
To which we are all very grateful.
Except my fingers are not grateful. Like, stop it. Okay, there we go. My dad sent me a video of my mom playing the piano. My mom was a concert pianist many years ago. She's 90 years old.
Wow.
And she was playing a song that she's going to be playing in a concert with a group. She's 90 years old.
Wow.
And she's just going No, I'm like, oh my gosh, is this even possible? How does a 90-year-old person do that? And then I looked at her fingers,
Yeah.
and she's just covered with arthritis. It's
No.
She's like almost sticks, you
Wow.
know, but still,
Yeah.
it's just crazy. So, whenever I get cramps like this, I'm like, it's nothing.
It's nothing.
My fingers still move.
Yes.
Except for right now. There we go. Okay. I'm sure you're going to edit this for time.
I'm not sure. I may just run it unfiltered. And just say, this is what it's like. You know, because I think there are people who will be curious of, you know, how do you figure all this out? And then you watch this and you realize you'll never figure it out.
So any type of wiring connector can't be in a place where it is going to repeatedly cycle through a bending motion. And that was really one of the biggest issues that I had early on, is not understanding
Yeah.
how to sort of tie off the connections.
You realize that the wires have to be able to move.
That's right, yeah.
That's one of the biggest challenges.
Yeah, when you're trying to connect a moving platform with wires that have to be 100%,
Yeah.
100% of the time,
Yeah.
you can't have it flexing back and
Right,
forth here,
right,
right? So
right.
that's why we're going to end up tying this down someplace.
Right.
And then we'll tie this down, and then the only thing that flexes is the actual
The actual wire.
wire itself.
Right. Right.
Yeah. And we're actually at a point where we can test. Okay. 50-50 chance. Without having it on the bench, you know, we're just sort of, oh, I guess we need to power it on. Do you mind power it on and yeah, we can pull those off.
Clamps off. Stay.
Oh. And the hot end is falling out of the block. Okay, in order to test it, I have to turn the hot end on. So let's go ahead and just put that back. Yeah, it's warm. A little warm.
Well, let's just bring the whole thing up where it belongs.
Yeah. You want to hold that while I home it, and that'll support it. Here we go. And then I'm going to come down. Good enough?
Yeah, just come on out. Good.
Okay. All right.
Hit it.
Let's do it. Luckily, the bed stays hot very, very long. It's got
Yeah.
a mass behind it, so it's still sitting at 52 degrees. Okay. Okay, we'll give it a few minutes to heat up again. Do you have a little piece of tape
For
just to hold that in place, just to tape it across so it doesn't fall?
Like wood tape or, yeah, wood tape.
Yeah, that size is good. Even. Yeah, perfect. I just want to keep it from falling out of there.
right.
Okay, there we go. And, no, not yet. I think once it reaches 165 degrees Celsius, it enables the motor.
Oh.
And you can start, yeah, there we go. That's a lot
And-
better, isn't it?
Yes, and we're turning backwards.
Yeah, we're going backwards.
We're going absolutely backwards.
It's okay. I just want to make sure that. Okay, so changing the direction is very easy to do.
Kind of walk us through it.
Well, once my brain gets back into this, I will. In essence, each one of these lines tells the machine something about its configuration. In this case, I'm looking at the direction of the drives. So I've got the three towers, 1, 2, 3, and their directions are set by either a S0 or S1, and they're all zeros because that's the way they're supposed to be. The other extruder system we were using needed the motor to rotate a specific direction.
Right.
So it was set to 0, and now we're going to change that 0 to a 1, and we're going to save this configuration change, and we'll reboot the machine.
Off.
No. Actually, it's already rebooted. So then we're just going to home it again. And we'll turn the heaters back on. I feel like I've done this a couple of times now. Okay, now let's check and see if the motor is rotating the right direction.
You got it.
Bingo.
Yep.
Okay.
Going that way.
All right. We can put the head of the Bondtech extruder back together.
Okay.
You need to hold anything for you there?
You probably want me to take the tape off, don't you?
Maybe. Sometimes it works better that way. I can do that. Okay.
And you can see, you know,
Yeah.
this is where the top sits, is right there. So
I gotcha.
there's no Bowden tube inside.
So much for that. It's at 210 degrees Celsius too, so it's not comfortable to touch.
Pliers here somewhere.
I think I can get it if I reach my hand across this way. I'm gonna cuss. Why is it not, oh, here we go. There we go. Okay.
Like a monkey and a football.
What are we doing, man? There we go. Okay. That's nicely machined.
Very nicely
Yeah.
machined. Yeah, they did a real nice job.
This is nicely machined too.
Thank you.
Kevin made that.
Is that 3D printed?
No.
No.
Oh. Oh, yeah, the body, yeah.
Okay.
Using your mill?
No, it was actually cut out of a piece of 1/2-inch plate aluminum. I just laid out the whole design for a flat sheet. I did it in CAD on the computer, and then I went out to my plasma table, cut the whole piece out that way. A little machine work just to clean it up, get it to fit just right. So it would clamp the motor and everything would work that way, and then just a little polish on it, and we're done.
Okay.
You got the turn screw?
I do not. I didn't pick it up.
Damn magnetic screwdrivers.
We're ready for you to put the filament inside there.
Okay. Are we up to temp?
Yeah, we're up to temp.
Has the smoke coming off your fingers will testify?
My fingers are up to temp.
Nothing like a big glob coming out the other end.
Look at there. I love it when it comes together like that. Good.
Putty knife somewhere?
Yep. There we go. So next step is to get our height, our Z height, right? Because
Correct.
We've moved
Right.
the hot end.
Right, because this whole thing has been moved up a little bit. So we'll pick up a little bit of overall height that we can print, but now we have to adjust
Yeah.
for the Z height where the hot end knows where the bed is.
I mean, I've sent a command to send it to 50 millimeters above the bed. In reality, it's going to be more like 75 because we've lost.
Right.
What's your guess as to how much height we have there? You think that's like 50 millimeters?
I'd say 50 to 75, yes.
So what I'll do is I will add 100 and we'll just step it down. And then once we get it right to where it belongs, I'll subtract whatever is left over
Right,
from what I added.
right,
And then that'll give us the height that we need to be at.
okay.
It's just M665 and then H for height. And then we're going to add 100, so it'll be 1,376.7. Okay. I need to home, which is G28. Now I'm telling it to stop 100 millimeters above the bed, and I'm just going to step down a little bit at a time. Okay, and 25 down, and 25 down. Oh, no, I'm going to go 5 at a time. So 5, 10, 15, 20. I'm going to step down by
Trapped.
okay, we're going to go up. Those okay?
Feels pretty good.
I'm going to go down.
Go down a touch. Just dragging.
Okay, that's the one, right?
Yep.
All right.
Just a little bit of tension on the piece of paper. You know, the step before this, paper moved freely. So it went down just the tiniest little bit. Now the paper just drags just a little. Just what we want.
And the value that I need to subtract now is 46.9. So let's go back to console. M665. And some people will make fun of me that I'm going to use a calculator.
Screw them.
Screw all those people. I cannot do simple math. Let's see. So 1376.7 minus 46.9 equals 1329.8. I'm just going to copy that. Set that right over here. Go H, Control V, 1329.8, and we'll send it to the machine, and we'll save it by hitting M500, which saves it into the memory. And let's home it. And we'll have it come back down again.
That's still the original nozzle.
Oh, did you want to switch that?
There are 3 new nozzles.
Yeah.
Do we want to switch?
That's totally up to you. Now's a good time to do it because we're setting the height. So over time, like if that nozzle has been run for hundreds of hours,
Since
it's going to wear down a little bit.
That's the original nozzle.
Okay. So then, yeah, you could either choose to use the hardened steel one or the is this just stainless?
I believe it's just stainless.
Stainless?
Yeah.
And they're all the same size, right? 1.2, which
Correct.
matches what's already on
Correct.
there.
Correct.
Yeah. Well, let's just check. Well, you know, since we're here, let's just check the bed height. I'm just going to come on down and we'll see what. So is it
Tight.
too much?
Tight.
Too little?
Totally loose.
Okay. Yeah.
Tight.
Tight.
Good.
So
Totally
the
loose. again.
difference is 0.05 millimeters.
Okay.
Okay. Let's subtract 0.5 millimeters from. Let's go minus 0.05 equals 1329.75. And console. save it. All right. Yeah, I think that was just an exercise because since we want to change the nozzle anyways, we're just going to get in there and I'm going to home it, and then we'll just do that right now. I've never used either of these two nozzles, so it's your decision as to which one you want to use. I would say the hardened steel one is going to last
forever.
Yeah.
Right.
I might as well
Good.
just throw that one on there.
So if that nozzle was the original, was that the oldest thing on this printer?
Could be.
Now, the oldest thing on this printer is me.
The frame, I guess.
Yeah, those little rollers that I made are still working pretty nicely.
Still work just fine.
Yeah.
Yeah.
Yeah, but those aren't original.
Oh, they're not?
No, we did change them.
Change those.
But what I started doing was every so often I'll bring out a little like 3-in-1 oil
Oh, yeah.
and just put a little drop on each roller just to lubricate it against the metal and also lubricate the bearing. Yeah.
That hurt. I think the first year I was building these printers, I must have had just blisters all over my hands. Like, I gotta fix it. So you get your hand in there
Yep.
and just burns and burns. But after a couple of years, it's either I wasn't fixing things as much or I knew not to touch hot things. It's maybe a combo of both of those.
Could be.
Well, what are you doing, Kev?
Arcing the filament at 100 millimeter so Steve can calibrate it, to calibrate the extruder motor so it will put out exactly 100 millimeter. So whatever the computer says, put out this much, now everybody's on the right page.
It looks like we need to do a little preheat still on that, so
Yeah.
why don't we just do a quick bed height
Z.
calibration?
Okay.
Z height. Okay, so for this, what we're going to do is I'm going to home the machine, and then we're going to bring the nozzle down fairly close, and then we're going to step it the rest of the way, and then we'll compare. Once it actually touches the paper that Kevin has, we'll compare that value against what the machine thinks that its Z height is, and then we'll be able to make some adjustments there. So let's see. We're going to go home. I'm going to type a couple of commands here. Z. I'm going to go 100 millimeters over the bed right now. 100. Send. Takes a few seconds
How come I always wind up on my knees?
because better you than me. Because you're the one who needs to pray to the computer.
That's what it is. That's what it is. Yes. I'm going to sacrifice a pussycat. Yes.
Right.
Work.
Okay, now we're going to just step down 25, 25, 25. And I'm going to go 5. Oh, okay, so we're already at 0, right? And the machine is set so that you can't normally blow down through the, too far. And so I have to look at the value that's in there, and I have to add a little bit of numberage.
Which is always the part that gets me mixed
Right,
up.
me too, for some reason. So first off, let's just do we're going to call out a command to show me what it is, which is M665. And it tells us that the home height is 1,329.35 millimeters. And I'm actually going to just copy that value so that I don't fat finger it. And then I'm going to type it in there, and I'm going to add How much do you think? We need about maybe 10 more millimeters down there?
Yes.
Okay, so I'm going to just say 1330, just to add 11 millimeters to it. And we'll send that, and we have to repeat the process of homing the printer. Now we're going to come back down again, and I'm going to bring it about 50 millimeters this time. We're just going to keep edging it a little closer each time. You know, the goal here is to not break the extruder off the machine.
Well, that's a good plan.
Yeah.
That's a good plan.
Always,
Yeah.
it's always better to not do that.
Yeah.
Okay, and now we're going to step it down again. I'm going to go 25, and now I'm going to go 5 at a time. And one more 5. Oh, we're already at 0, so we didn't quite make it down all the way. So I have to repeat that process. It's okay. We're just going to keep working our way through it. And again, we'll home the machine. We're going to go down to 50 again. Kevin, how many prints do you think you've made on this machine so far? Hundreds? Several hundred?
Probably in the 50, 60, 70 range.
Okay, and again, stepping. And I'm going to start stepping a little, well, maybe, no, that looks pretty close, doesn't it? Okay.
No, you're still that far away.
Okay, now we're getting closer.
No, we're tight.
We're tight?
We're tight.
Okay, so let me go back up and loose.
Loose.
Now remember last time we did this a while back, we got it exactly where we wanted to. Then when we homed and came back down, it was just a little too tight. So
Right.
I think I'm going to leave it right there.
Okay.
It's very close. It's just half of a millimeter off of what I typed in. So let's just subtract half of a millimeter off of this value, which will be, think about this for a second, 1,340.7. Okay, that's it. Send that. And now let's home the machine. We'll come back down to our 50 millimeter mark again. And run it one more time.
Tight.
Too tight?
Tight.
I think it's probably because there's a little bit of plastic there. Let me just,
Loose.
I'm going to go back down again.
Tight. Loose. I'll leave it right there.
Right there?
I will leave it right there.
Okay, so I'm gonna do one more change. Adding 0.55, which means we're now at 1,341.2. Getting close. So, machine control home.
What are you doing there, Steve?
Oh, I just checking to see how whether there was any binding, and it's perfect. I'd say those are really nicely set up, so I'm happy.
Tight. Those,
Oh, you know what I'm doing? I'm going. Okay. I'm going to subtract. Is it right where we need to be, or is it too loose?
drop down a little, let's find out.
Like
Drag.
really close.
Drag.
Yeah, it's really, really close. Okay. It's too tight. Subtract. So now it's going to be 40.4. Send that. Oh, I pushed the wrong button. Hold on. Okay, down we go.
Tight.
No, it's a little melted plastic, I think, that's causing that.
Oh,
But I think we're probably let's just try that.
yeah.
Let's just see if that actually is going to print.
Yep.
So do we have now that we're heated up, let me just bring it all the way back. Now this next step is going to take about 30 seconds, and we're going to extrude 100 millimeters of plastic. So, extrude.
We don't use that P word here.
Plastic?
Yeah, we use that word here.
Oh, we use the word composite? No, what do we use?
Filament.
Filaments.
PLA,
Okay.
something.
Oh, our polylactic acetate. Polylactic acid. You can cut all that out.
Oof. So close.
Oh, okay. So it's a little short, which means that we just need to increase the steps per millimeter of the extruder, and I'll do that right now. That has to be done inside of the file.
You're marking that again, Kat?
Uh-huh.
And
Because Steve's going to go into the code and he's going to tell the motor, turn just a little bit faster. We're going to give you 1/2 of an amp more or something, just to get it calibrated so it turns exactly the same as what we measure. So when we tell it put out 100, it puts out 100.
whenever I send that command, everything resets, and then I've got to get everything back. I had to turn the heaters back on. So now let's just do that extrusion again. It should be nice and warm and happy, and we'll just do it again. We will do it again. Let's see. We will check the job status. What's going on? Oh, there we go. Oh, it was waiting to get back to temperature.
How dare it follow the rules? Jeez.
I went a little too far.
Too much.
A little too far. Because I pushed the button twice.
Oh no.
Oh, okay, we'll have to just mark it again because it's going to go 200 millimeters now.
Can't you just push emergency stop and just let it reboot? It's going to reboot anyways.
Well, no, we haven't actually. We're just gonna run it again immediately as soon as it stops.
No, okay.
But you'll mark it first,
Right.
and then we'll run it.
Oh boy, we're making spaghetti.
It's got like an arrabbiata sauce on it or something there.
Yeah.
Ready?
Okay.
You don't have to wipe the little nose?
Nope.
No, we don't.
We're only concerned
Yeah.
with that top.
Yeah, we're worried about where that little mark winds up compared to that. We don't care what happens there at this point.
Oh, hurry up. Well, that looks just exactly the same. Would you measure the distance between the mark and the top of that tube, and then we'll actually just use a little bit more scientific.
I mean, rather than guess? Come on. We're guys. I'm showing 7.12 millimeter.
Okay, so okay, that's actually 714. Okay. That's interesting. So it's actually, hopefully I'm not going the wrong direction on this calculation too. Okay, 506. So changes. Yes, reboot. Here we go. Again. Just fall a little bit there. There's a very real chance that I've reversed my But if it does, then I know exactly what to do on the next
No.
try. Try it again, and we just have to wait until it reaches there's a temperature window.
Right.
The extruder won't extrude, and it's
Right.
just about there. There we go.
With the big hot end that's on there, can't we go a little faster on the feed to do this?
What I've done is I'm using the feed rate that we used originally.
Okay.
Just because I don't know the characteristics of this
Hmm.
yet. I mean, we probably can. What we'll do, as soon as we get it calibrated, I'll double the speed,
Yeah.
run it again, and we'll see how accurate it is.
Oh.
And just because now the new extruder has double gears and it's gripping
Right.
the filament on
Right.
both sides.
Both sides,
We
right.
should be able to just crank
Yeah.
it way up. You're right, we
Yeah.
should be able to, but I'd like to start conservatively first. Oh, that is closer.
It's much
That's
closer.
closer, okay.
Yeah.
So I am going the right direction. Here we go again.
I don't know.
Okay, machine control. Now that hot end cools down amazingly quickly when you remove power. So it lost 5 degrees Celsius just between that.
Wow.
that.
Huh.
Okay. We are ready to go. So Kevin, a while ago you bought a machine to extrude your own filament? Was that years
No.
ago? No?
No.
Oh, no, it was a machine to join filament
It was a
together?
machine to join them.
Oh, okay.
It was
Yeah.
like it was like a little soldering iron that they put a pair of clamp ends on it.
Yeah.
So you could take the two halves of the filament, stick it in there, clamp it together, and it was supposed to melt the filament, make it flow together, and that way you could join two partial spools and have a full spool out of it. The only problem is there's a little bit of flashing that you get where the joint is. We're about a millimeter short.
That's interesting, because I thought I gave it plenty of change here. So we're surprisingly far beyond what the manufacturer specified for that. So we're going to go to 2.5. Okay, one more time. Waiting. There we go. Waiting.
But yeah, I tried that machine to join the filament several times. I had one success out of it where I could join two spools and clean it up enough where it would actually run down through the extruder without getting caught,
Oh, right, because it would leave a little bulge.
because it would leave a little bulge on the filament. So I had to sit there with a piece of sandpaper and
that's
just
kinda
sand that down, just to get it to finally slide through. The second time I tried it, I tried joining two short spools and it broke.
Yeah.
The join broke because it was pulling it off of the reel.
Yeah.
And had
So
to
you wasted off.
had to feed it anyway. You know, had to stop and change it and feed it, and yeah, it doesn't quite work the way they thought it would.
So that falls under the umbrella of good idea, bad execution, kind of a.
And I'm sure a lot of it was me. I'm sure, but the fact that the little attachment that you put your filament in was so loose that it allowed that little flashing on the joints.
Yeah.
It just wasn't fit quite right.
Yeah.
You know, I think they were trying to fit several different sizes of filament.
And was that for this larger filament, or was it for the filament?
Well, it does both. It does the
okay.
3 millimeter as well as the, look at that.
I say we're on.
Dead on, brother. Dead on, finally.
Okay, so the next step is to try a print. Do you have something we can print?
I'm sure you can look in there and find something.
Okay. Well, I guess you'll have to tell me because you have a lot of files here.
I would go.
Twisty Canyon.
I would go to. Yeah. Oh yeah. Yeah, Twisty Canyon. That's
Twisty
fine.
Canyon?
Yeah, that's the one that failed last time. So
Okay.
get to work.
Get to work. No, I think I must have missed something there because that's way too high. We will pause that. Give me just 1 second to think about that. I know why, because I reset the machine before saving the command. Luckily, it has memory of the last command that I sent, which is the height. So we'll send that, and now we're just going to test it before we go crazy. And I'll home it. And it'll come down to 50 millimeters over the bed, and we'll just run it again. In the manual, did it say anything about how tight to set the
No.
the spring adjuster?
No, it didn't.
Okay, so we'll just have to sort of play that by ear. Okay, I'm going to go down 25 at a time. 25. And I'm going to go up. See, it's the plastic, I think, is what's
Yeah.
causing it.
Yeah. Tight.
Yeah, it might be a little too tight.
Yep.
Okay, so let's just modify that real quick. We'll shorten it up by 0.05. So that would be 0.35 and send. And then we're just going to start our print job and see where that sets us up. So G-code files, Twisty Canyon, and away we go.
Get off there.
It's a cool nozzle extension you put on there. And finally it kicks in. Grab that little... That looks pretty good.
And this is just doing a little outline, you know, and then it'll get this done. That way everything's primed, and then it'll go in and actually start doing the print itself.
It looks like maybe I should step it down by 5/100ths of a millimeter. It looks a little bit high. What say you when you look at it?
Yeah, I'd go down a little.
Okay. So it should go down by 5/100ths of a millimeter.
It's still round.
Okay, so I'll go down another 500. So now we're. I think that nozzle you printed was a little low.
Mm-hmm. Yep. Stop it. Stop it. Pick it up.
Yeah. Okay, and home it all. Is that something you can push on a little further up onto the?
I'm hoping, yeah.
Do you need one of these tools over here? You could just clip. You could clip that.
Brett, bring this.
Hold on a second. I gotta go down.
Gotta go down some, yeah.
So that's the nozzle for the fan?
Yeah.
Right. Maybe a little bit more just right there on that side as I look at it across this way. Okay. So should we take it down to the bed and just take a quick, just leave that there for a second?
Good.
And then I'll go down to the first layer level and I'll move it across that and see if you've cleared it.
Okay.
Let's see, that would be, hold on a second. I'm gonna go this way. Cleared?
It's clear, yeah. But you're way high.
We're still high?
You're way high.
Oh yeah, that's right. I'm 5 over, so hold on. There, now, right?
Try it.
Okay, and
You good?
good?
Yep.
All right. Let's start our print job.
And I still remember one of the very first things you guys told me when I got one of these printers was the first thing you want to do is make yourself a trash can because there's always trash.
So true. That's already looking still rounded, you think, or is it a?
It still feels rounded.
Let's wait till it starts doing an
Wait
input
until it starts
pass so we
doing
can
it.
see
Right.
exactly how it
Right.
lines up. Yeah.
Right.
When it's rounded, what does that mean? It's not close enough to the bed? It's
The
not-
the nozzle
Right.
is a little too far away from the bed,
Yep.
and we're talking hundreds of a millimeter. And of course, your first layer always needs to go really slow.
Yeah.
You want to make your plastic bond to the hairspray.
Right. Oh, I don't use that to make it stick to the bed. I just like the smell.
Oh, you s-
Yeah, I just like the smell.
I wouldn't know anything about that. But it does have a nice smell.
It does have a nice
I mean,
smell.
old ladies must really enjoy their mornings.
I guess, yeah.
That is like beehive style.
That's beehive
plastic,
stuff.
right? Yeah.
Yes, yes. You can fix bridges with that stuff.
Does this have one outer layer, one perimeter, or
Yes.
just one? Okay. Here we go. Okay, so it does look like it's a little too close, a little too far apart, I should say. Yeah.
Oh, yeah.
Yeah, so I've just dropped it down by 0.2 of a millimeter. And we're still too far up, right? Yeah. It's getting closer.
We're trying to fix this,
The gaps.
the gaps. The filament is not printing where it's touching one another. It's got a little gap in between it like that. So we can lower the head. That'll help the filament spread out a little bit. Because especially for the base, you want those touching. You want those all nice and tight together.
I'm going to wait for it to turn the corner and go back the other way, and it should be a lot tighter. It is. Look at that. We're almost there. So I clicked it again. So this is another 0.05 of a millimeter. So on this pass, it should be even closer together.
Now the 500 is down.
That's right.
Right,
Yeah.
yeah.
Yeah. Okay, and I'm just going to do it one more time after I look at the next pass. Okay, one more time. That's close. Okay.
So they used to call 3D printing rapid prototyping.
That's right, yeah.
So if this is rapid, how slow was the other way?
Well, they were using,
Hammer and chisel.
well, they're using mills and, you know, they had to make it out of metal and, didn't they?
That's right, yeah, exactly.
And hammer and chisel.
Or carve it out of clay, carve it out of wood, make a mold, pour it. Yeah.
I think a lot of the old prototyping was just done, well, especially for things that were going to become a mold, they would use oak even, and they would just carve
Right,
them, right? I mean,
right.
in the old days.
Yeah. Yeah, you used to see the videos of the old designers in the car industry working on a full-size block of clay
Oh, that's right.
and literally just sitting there and carving out the whole shape of the car.
So Steve, you're just lowering it a little bit?
Yeah, I lowered a little bit, and then I have to wait a few layers because the layer previous is not flat enough, so you have to wait for it to fill at least 2 layers beyond, so it takes a little while to dial it in. But you can already tell that it's getting a lot closer. I think this next pass is going to be right on the money. And so what I'll do is I'll add that value to our height value. These are the critical times, so I'm going to concentrate on what I'm doing. So now I'm going to cancel this print job,
Okay.
and then I don't want to send the command while it's printing on the off chance that it decides to do something nefarious.
Oh, it's a computer. It won't do anything on its own.
Once bitten, twice shy, is that what they say?
That's how they say it, yes.
So I'm going to go to 50 above the bed again, and we're just going to slowly work our way down. I've been known to type in the wrong numbers
On occasion.
on occasion,
Yeah.
ending up in a not so fun crunching sound. That's actually kind of fun.
Yeah, it's kind of different. Well,
Not that there's any practical use for it. Of course, not everything about this machine is intended for practical use.
that is true. Tight.
Yeah, but okay, that is kind of interesting because I've been adjusting the printer down while we were printing. and I adjusted it a lot. And now you're telling me that the calculation is taking it too far.
Did you take off your baby steps down?
Oh, let's take a look. I didn't. That's exactly right. Thank you for noticing that.
Not that I would have ever done anything like that. No.
So let's just do it again. Here, we'll just go up and back down again.
Now Kevin doesn't have to do this every time he does a print, once
No.
it's set, right?
Once it's set, it should run that way for a long time. So let's see, we're going to go to 5 above the bed now. 5 millimeters above the bed. I always hold my breath.
Yeah, rolling. Tight.
Tight.
Good.
There's plastic there, I can see
Yeah.
it.
Yeah.
Yeah. And let me rewind the plastic just a little bit so it doesn't keep.
You mean the PLA?
Yeah. Oh, the PLA. Yes, the PLA. How's it looking right now?
I'd say you're tight.
Well, let's just try the print job and see where it takes us.
Okay.
So we're going to go G-code files, Twisted Canyon, and we'll start this print job and see.
Did you save it?
Yes, I did save it.
Okay.
Thank you for asking.
Gonna have to do a little cable management here when we're done.
Right.
So why didn't you put down more
That's a
hairspray,
A
Kevin?
lot more.
You don't have to put hairspray on it every time. I normally put a lot on when I do. Cables are dragging.
Is that like a health-related issue? My cables are dragging?
Yeah, but only for guys. Yes.
Oh, okay. Then we won't mention that again.
Yeah.
Well, it's obvious we are much closer to the bed now.
Oh yeah. That's nice. No, that's flat. That's
Yeah.
nice and flat right there. And it always prints the first layer slightly lower, right?
Yeah, for the adhesion to
Right.
get it to.
Right.
The last thing you want is to end up with a 45-hour print job up here and have it go pop and come off the bed. I'm
Oh,
sure.
we've
I'm sure
never
you.
had-
No, we've never had that happen either.
Yeah. The best solution is just to have your print auger itself into the bed
Right.
on the first layer.
Right.
I kind of feel like maybe we are a little too close to the bed on this, so I'll probably end up stepping it up a little bit. Oh, I don't know. That looks pretty good. It's a little too close to the bed. And the way I can tell is there's ridges. So if it's extruding too much, it's not a flat, totally flat surface. It's sort of a,
Yeah.
it's
Yeah.
squeezed down the sides.
It's plowing.
Plowing through, exactly. Yeah. So I just moved it up ever so slightly. I think we may be really, really close on that. The nice thing about the bottom layer is when your print's done, you don't see that plowing. You turn it over, and
Right.
it's just a beautiful.
Yeah. Yeah. Beautiful flat piece.
Yeah.
Yeah.
So I think we may say that that's where we want it to be.
Okay.
You want to just touch it real quick and make sure that you agree with the plowing action? Okay.
Yeah, and you can definitely feel it at the beginning, and where you've adjusted it, it's a little bit less over in here.
Correct. Yeah.
So,
So I will send another, we'll stop this one again, okay?
okay. And you can see how well this is sticking. Wow.
That's great. That's what we want. Okay. In this case, so I want to bring it down by...
But yeah, now I'll put a little more. 1340.95 inch. So you see, so this was their first try. You can see all the little gaps in the lines of filament. And this is the one we just did, and you can see it's completely solid.
And that just had to do with the Z height.
And that's all Z height, yeah. That's all Z height. And this is just, this is part of the setup. You make a major change in the machine, you got to go in and massage all the settings and get everybody happy, get everybody talking to one another.
Yeah, thinking about how many hours this machine will be printing with these settings, it's a very short period of time to get it dialed in properly.
Well, the longest print I did was 5.5 days of continuously running.
Okay, and
Oops. Sorry, sleeping.
okay, sleeping on the job. Well, that's where it wants to be. So
Okay.
let's just print again. I'm already liking the look of that. That looks just about where I would expect it to be.
Yeah. Slightly taller.
That's right,
just the slightest little bit taller.
1/10 of a millimeter difference.
Yeah. It's not just flattened out.
Right. I think I'm noticing that it's a little flatter on this side than it is on the other side, which indicates to me that I should come back with I have a new bed leveling probe.
Oh, cool.
And we can run another bed level on it.
Oh, cool.
So we can do that on Friday maybe if you want to.
Mm.
Or whenever.
Have to check calendar on that
Okay.
one.
This is a beautiful color of PLA though. I really like this.
Yeah.
Okay.
Gonna wrap, you guys?
I think that's a wrap.
Cool.
What do you think?
I think let's let it run and we'll see what happens.
Business. So the takeaway is we've added some height to your
Right.
print by moving the
About
extruder.
100 millimeter, yeah.
And we've and you'll be playing with the speed as you go along,
Right.
so then you can
Right.
basically dial in how fast
Turn
you
it up,
want.
yeah.
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 And then you'll roll your experiments and speed back into your slicing, so that you'll just slice it at that speed and
Right.
just go on forward.
Right, right.
Yeah.
Cool.
Yeah. Okay, man. Good to go.
You're the man. Thank you, brother.
Happy to help. Happy to be part of the Caron.
The Team Caron, yes.
There you go. All right, man.